Today's lesson is over 2-4. This is our second day of 2-4. We're spending two different lessons on this. Our objectives for this one is to solve equations in one variable that contain variable terms on both sides. Also, to identify equations that have one solution, no solution, or all real numbers as a solution. You need to go ahead and write these definitions. The first one is an identity, and that's an equation that is true for all values of the variable and has infinitely many solutions. So no matter what number you pick, it's going to be a solution. The next one is contradiction. It's an equation that is not true for any variable or any value of the variable and has no solution. So no matter what number you pick, it's not going to be a solution.
Pause the video and make sure that you get these down before you continue on.
Alright, these next couple of slides I want you to watch, but I don't want you to write anything down. We're going to show modeling with algebra tiles, but again, you do not have to write them down. This first one says 2x plus 3 equals x plus 1 plus 2. To show this one on the left-hand side, we have 2x pieces and 3 unit pieces for 2x plus 3. On the right-hand side, we're going to have 2x pieces from here, and then 1 unit piece, and then another 2 unit pieces. Notice that each one on each side is exactly the same. They both have 2 x's and they both have 3 unit pieces. They are exactly the same on both sides. If I'm showing this algebraically and I combine my like terms on this side, x plus x is 2x and 1 plus 2 is 3. So again, you can notice that I have exactly the same thing on both sides. This is called an identity, and it's going to have the answer of all real numbers. This next one, we have 2x plus 3. So I have 2x pieces and 3 unit pieces.
And again, you're not writing this, you're just watching it.
Then we have 2x plus 1. So I have 2x pieces and 1 unit piece. If I subtract 2x from both sides, or from each side, and cancel out my 2x's, notice that I have 3 unit pieces on this side and only 1 on that side. So these are not the same. And algebraically, if I take and subtract 2x from both sides, the 2x is going to cancel here, and the 2x is going to cancel here. So I'm going to be left with 3 equals 1. 3 equals 1 is not a true statement. So it is a contradiction and has no solution. This is our first example. You're going to go ahead and write this one down. So take a minute and go ahead and write it. 10 minus 5x plus 1 equals 7x plus 11 minus 12x. We're going to go through the 5 steps of solving an equation. The first one is, are there parentheses? And in this case, we don't have any parentheses. The next step is to look for like terms. So I'm going to look at the left-hand side of the equal sign and say, is there anything over here that I can put together and combine? And there is. I can put together the 10 and the 1 because they're both numbers with no variable attached. So I would say 10 plus 1 is 11. And on this side of the equation, I can put the 7x and the minus 12x together because they both have x's. You can see that here because the 10 and the 1 are in purple, and the 7x and the 12 and the negative 12x is in green, so you can tell that you can combine those. Also, from the first step to the second one, I went ahead and added the opposite. Where we had minus 5x, I put plus negative 5x, and where we had minus 12x, I put plus negative 12x. So again, when we combine those, I have 10 plus 1 gives me 11, and 7x minus 12x gives me negative 5x. Our next step for solving an equation is to look to see if we have variables on both sides, and we do. We have an x on the left-hand side of the equation, and we have an x on the right-hand side of the equation. We're going to move the one from the right to the left. It's a negative 5x, so we're going to add 5x to both sides. And both of them are going to cancel. Negative 5x here cancels, and negative 5x plus 5x cancels, and negative 5x plus 5x here cancels. So I'm left with 11 equals 11 because my x's canceled out. Then I'm going to ask myself, is this a true statement? And it is. 11 does equal 11, and they're exactly the same on both sides. So this is called an identity, and my answer is all real numbers. You need to make sure and draw this box and write in your answer, because the answer is not 11 equals 11. The answer is identity, all real numbers. It says true statement. Note the solution is not n equals 11. The variable has been eliminated. It says this is an identity. All values of x will make the equation true. All real numbers are solutions. And if you can see down here at the bottom, we've checked with a 2. Everywhere we saw an x and we got 1 equals 1. That's true. Over here we checked with a 5. Everywhere we saw an x we plugged in a 5, and again it checked out. So it will check out for any number that you check, which is why it's all real numbers. Okay, you do not have to write the words that are over here, and you do not have to write the 2 checks at the bottom. Okay, since it has all real numbers as a solution, you do not have to check. Number 2, go ahead and take a minute and write that down. We have 3 parentheses 4x minus 1 parentheses plus x equals 13x minus 4.
The arrows don't come in.
We're going to use the distributive property, and it says you may add the opposite, so we change the minus 1 to plus a negative 1 and the minus 4 to plus a negative 4. And here, go ahead, even though the PowerPoint doesn't show it. Okay.
Go ahead, keep talking.
All right, so we're going to take and distribute our 3. So we're going to multiply 3 times 4x and 3 times negative 1. Because we do have parentheses in this problem, and that's our first step, is to get rid of those by distributing. So when we distribute, we say 3 times 4x is 12x, and 3 times negative 1 is negative 3. We bring down our plus 1x equals 13x plus negative 4. If you notice up here, it was just x, and we went ahead and put a 1 in front of that x to show that there's a 1 in front. Our second step after getting rid of our parentheses is to look for like terms. So on the left-hand side again, I'm going to look to see if there's anything that I can combine. I can combine the 12x with the 1x because they both have x's. So whenever I put them together, 12x plus 1x is 13x plus negative 3 equals 13x plus negative 4. I couldn't combine anything on this side because the 13 has an x and the 4 does not. Now we look and say, do we have variables on both sides? And we do. We have an x on the left-hand side and an x on the right-hand side. So we're going to move the one from the right to the left. It's a positive 13x, so we're going to subtract 13x from both sides. 13x minus 13x here cancels, and 13x minus 13x here cancels. So we're left with negative 3 equals negative 4. This is not a true statement. They are not the same on both sides of the equal sign. So this one's called a contradiction, and our answer is no solution. Again, our answer is not negative 3 equals negative 4. You need to actually write contradiction, no solution. That is your actual answer. The good news is if we don't have a solution, we don't have a solution to check. So you do not have to check this one. It's a false statement, and it says the variable term is eliminated. It says it's a contradiction, so no matter what value we pick for x, it is not going to be a true statement and will not check. Take a minute and make sure that you get all of this written down. All right, number 3. Go ahead and write it down. N minus 15 equals 7n plus 3. Again, we're going to use the same 5 steps that we've been using. First of all, is there any parentheses? No, there's not, so we can move on to step number 2. Step number 2, ask if there are any like terms that we can combine. And if we look at this side, there are no like terms. And if we look at this side, there are no like terms because the 7 has an n and the 3 does not. And here we have an n and the 15 does not have an n. So now then we need to look and see is there variables on both sides. And there is. There's an n on the left and there's an n on the right. And we're going to go ahead and put a little 1 in front of that n so that we know that it's a 1.
And add the opposite.
And we're going to go ahead and add the opposite. We have minus 15, so we are going to go ahead and write that as plus negative 15. We do have the n's on both sides, So we're going to take the one from the right and move it to the left. So it's a positive 7n, so we're going to subtract 7n from both sides. 1n minus 7n is negative 6n. We're going to bring down our plus negative 15 equals, and we're going to bring down our 3. Notice that I only subtracted 7n from the other things that had n's. We had an n here and we had an n here. The next thing is to add or subtract. Here, if we look to see what's being added or subtracted, negative 15 is being added. Since it's a negative 15, we're going to add 15 to both sides. So we get negative 6n equals 18. And finally, we're going to multiply or divide. The negative 6 is right next to the n, so it's being multiplied. So we're going to do the opposite of multiply, and we're going to divide. So we're going to divide both sides by negative 6. And that's going to give us n equals negative 3. This one is on an identity or a contradiction. It actually has an answer. Its answer is n equals negative 3. So negative 3 is the only thing I can plug in everywhere I see an n and get a correct check. Since you do actually have a solution of negative 3, you do actually need to go back and check that solution. So we're going to go back to our original equation before we did anything to it, and everywhere we see an n, we're going to plug in a negative 3. Instead of n, we put in negative 3 here. Instead of n, we put in a negative 3 here. Negative 3 plus negative 15 is negative 18. And 7 times negative 3 is negative 21. And then when we add 3, we get negative 18 equals negative 18. And it checks out. So again, you do not have to check if it's an identity or if it's a contradiction. But if you actually get an answer, like here we got n equals negative 3, and the variables do not cancel, then you must check.
You need to have all of that work. You need to have all of that work down before you move on. All right, now we're going to look at number 4. All right, we're going to look at the next equation, which is 4y plus 7 minus y equals 10 plus 3y.
Take a minute and pause the video and go ahead and try this one on your own. Once you've tried it, go ahead and restart the video to see if you got it correct.
Okay, I did go ahead and write in plus and negative 1y there. We added the opposite and I added the 1 in front of your variable. We're going to follow our steps for solving this equation. We're going to look for parentheses and we don't have any. So the next thing we're going to look for is like terms on the same side of the equation. So we look on this side of the equation and we do have like terms on this side of the problem. We have 4y and negative 1y. 4 minus 1 is going to give us 3y. And I'm going to bring down my plus 7, my equal sign, my 10, and my 3y on the other side. So now, I don't have any more like terms on the same side of the equal sign. I have to pick a side and move my variables to be on the same side together. So for this problem, I'm going to move this 3y, and I'm going to say minus 3y, which cancels, and minus 3y, which cancels. And that leaves me with 7 equals 10. Notice that my variables totally canceled out. They're now 0. They're gone. I have a statement, 7 equals 10. That is not a true statement. 7 does not equal 10. So we call this a contradiction. So your answer is to write the word contradiction, no solution. Again, contradiction, no solution. That is your answer. Because there is no solution, I cannot check this problem. Can you click? You'll have to do both. Here, sorry. You see down at the bottom it says the equation 4y plus 7 minus y equals 10 plus 3y is a contradiction. No value of y, no matter what I plug in, will ever make that equation true. There is no solution for y. Make sure that you have that work down before you move on and that you've written these words, contradiction, no solution. All right, let's look at number 5. Write down this problem, and as you're writing it down, I want you to go ahead and draw these arrows from your -2 to show that you're distributing it to the x and to the 3 in parentheses. Once you've done that, go ahead and pause the video and try to solve this problem on your own. Okay, hopefully by now you've taken the time to work this problem out on your own and see what your answer is. Again, if you got it wrong, that's perfectly okay, but make sure that you get your work fixed. And if you don't understand exactly where you went wrong, make sure that you mark it so we can come back to it tomorrow in class. All right, the first thing we're going to do is distribute our -2. Keep in mind it is a -2, so it becomes -2x plus -6. You can also write this -6 as -2x minus 6 or plus a -2/6. Either way works just fine. Bring down your equal sign. You have 4x minus 3 on this side of the equal sign. So now we're following the rest of our steps. We've worked our parentheses and we look for like terms on the same side of the problem. We don't have any like terms on the same side of the problem. So now we look for variables on both sides. We have a 4x and a -2x. It doesn't matter, again, as long as you pick a side, it doesn't matter what side of the equation you move your variable to, but you have to pick a side. So we're going to move the 4 to be with the 2. We do that by subtracting 4x here, which cancels out, and subtracting 4x here, which gives us -6x minus 6 equals -3. Now we can add our 6 plus 6 equals, I'm sorry, let me erase that, I didn't mean to do that. So we have our plus 6, that is a 6, I promise, and then our plus 6 over here, this cancels, and we're left with -6x equals 3. Now my x is not by itself, even though there's nothing on that side of the problem with the -6x, there is still a -6 attached to it. When a letter and a number are touching, they're being multiplied, so we have to divide. We're going to divide by -6 to get our x by itself. So we divide both sides of the problem by -6. This cancels out. 3 divided by -6 is equal to -0.5. So x equals -0.5. You see the note there at the bottom. It says this equation is neither an identity nor a contradiction. There is one solution. The variable is not eliminated. The solution is not all real numbers. Very clearly, the solution is x equals -0.5. So, because we have one solution, we do have to check this problem. We're going to look at how this check looks. You're going to go back to the original problem, and you're going to plug in 0.5, -0.5, every time you see an x. You have -2, open parentheses, -0.5 plus 3. And over here you have 4, open parentheses, -0.5 minus 3. You combine them. This gives you 2.5 inside the parentheses here, and now you're going to multiply -2 by that. And then here, 4 times 0.5 is 2, plus 3, plus a -3. Both sides give you -5. It does check. It is true. This is equal. Excuse me. It is a true statement. Those are equal, so the solution does check out. X is indeed equal to -0.5. Let's look at number 6. Go ahead and try number 6 on your own. Pause the video now and try to work this one out. Don't forget to draw your arrows. Okay. The first thing we look for is parentheses, and here we have parentheses. So let's go ahead and distribute. Let's go ahead and bring down our negative 14 because we're not messing with that. 3 times C is 3C. 3 times 7 is 21. Bring down your equal sign and go ahead and bring down the rest of the problem for the time being. Now let's look for variables on this, like terms on the same side. Over here, I have 2 different C's. Over here, I have negative 14 and 21. Those are going to be my like terms. So on the same side of the problem, let's go ahead and combine those. I have a positive 2C and a positive 1C. I'm going to combine those by adding, and it's going to give me 3C plus 7. I'm going to bring down my equal sign. And I'm left with what I have on the other side, which is a negative 14 and a positive 21. So I'm going to go ahead and combine negative 14 plus 21, and that's going to give me 7. And then I have my positive 3C still over here. So I have to move my variables. I have variables on both sides. I have to move them to be with each other. So I'm going to subtract 3C on this side, and I'm going to subtract 3C on this side. Cancels out on that side, but it cancels out over here too. And I'm left with 7 equals 7. Because I'm left with 7 equals 7, my answer is identity. All real numbers. Meaning, no matter what I plug in, for C, I'm always going to get, it's always going to be a true statement. All real numbers. So my answer is identity, all real numbers. Because any number I plug in for C is going to make this true, I don't have to check this problem. Alright, we have covered our objectives for today. We have shown you how to solve equations in one variable that contain variable terms on both sides, and we have shown you how to identity equations that have one solution, no solution, or all real numbers as a solution. Thank you for watching.